Welcome back to section 14.1, and we'll continue on with our last transformation, which is a glide reflection. And a glide reflection is the end result of combining a reflection and then a translation in the direction of the line of reflection. So what's important to remember here is that there is kind of an order. We want to do our reflection first and then our translation. So we're going to bring those vectors back. So let's look at Z. Here we have the point Z. We're reflecting it over this line of reflection first. So we reflect it, so it's this far from the line of reflection, so now it moves this far. And then we want to move it in this direction. So then we move that result to this direction, and that's how we end up with the image Z prime. And the same thing with Y. Let's look at an example here. So construct a glide reflection of rectangle ABCD using vector V and reflection line L. All right, so let's get these colors back. All right, so first we want to reflect over which line here? And they say L. That's the x-axis, but they called it L. That's fine. So that's our first step. So first we're going to reflect. Even though they said the vector first, we always want to reflect first. So we're 2 away here. Oop, let me use a different color. So this is not D prime, it's important. This is kind of just like the image of D. We're still working on it. And again, you can reflect each point, or you can say, okay, now that I have that this is kind of D, and I'm just going to erase those later, but I know that A is going to be 1, 2 away, and then B is going to be 1, 2 away. Okay, so I'm not calling this yet. I'm dash lining it because I've just done the reflection. Now I need to do the glide or the translation. So what is this vector? So from the point, I'm going to go down 1, 2, 3, and then I'm going to go to the left 1. So for each point, I'm going to do that. So from A, I'm going to go down 1, 2, 3 to the left 1, and this becomes A prime. Here, I'm going to go down 1, 2, 3 to the left 1, that becomes D prime. And again, you might be saying, listen, I know that these transformations keep the lengths the same, so I could just build out where, you know, C is 1, 2, 3 away, 1, 2, 3 away, and that's true. And we could double check that here. Let me get the green. We're going to go down 1, 2, 3 left 1. It does work out, and so this is going to be 2 away. That's going to be B prime. And so here is the result of that glide reflection. All right. So what about the effect on shapes? Well, we've seen that, right? So before we saw the points, but now we're looking at the shapes. We already saw that what we can do here is we can do the exact same thing we would with a point, because it's just a shape. It's just kind of looking at those points individually. And so when we reflect, it's the distance from that line of reflection. When we translate, we take this distance and this length, and we do that with each point. We do that with each point. And then the center rotation, so we've got L is going counterclockwise 90, that's the image, excuse me, counterclockwise 90 degrees this way. So we've got our point L, and we want to go 90 degrees. And that's how we end up with that there. That's 90 degrees. And if we were to look at each point, K, this distance here, that angle is going to be 90 degrees, and so on. So what's really important here is I want you to explore using Desmos. This may be the first time we've done an official Desmos. So what you're going to do is you're going to Google Desmos Transformation Golf Rigid Motion, the whole thing. When you get into it, you will end up on a screen that looks like this. You're going to click that student preview. Now you're going to see the answers in the bottom, but this is really just about playing, and they are hard. Notice the word challenge, right? Just have some fun with this. I really want you to look around and see how these things are made, see how they transform, have some fun, and then click back in here when you're done. Now that you've had that opportunity to play with Desmos, now go ahead and complete this exploration here and see if you can kind of summarize what you've learned so far in this space here. So what makes these transformations so special is the fact that they preserve the distance between all pairs of points, And so we're not actually changing the shape. We're not changing anything. When we do transformations, reflections, translations, rotations, and glide reflections, we are not changing the distance. That's why once we got one point, we could figure out the other points. So that is what's really special about transformations. Go ahead and give these a try. Press play when you're ready to see the solution. And that concludes 14.1.